So here we are again. Hello, everyone. I'm Rodrigo from Devpass team. I'll be your host for today's talk. Today is a very special day. We are making our first tech talk for our global community. Thanks a lot for attending. Follow us here on YouTube and other social networks in order to don't miss the next ones, okay? We are receiving a very special guest today. Emmanuel Okwara is an iOS developer, a delivery hero, and content creator on his channel on YouTube. If I were you, I'd follow him right now to check out his amazing content on iOS development. But before passing it to Emmanuel, I would like to share a bit about Devpass with you today. So, Devpass is a global platform where tech leads share knowledge through live hands-on learning experiences. What we mean by learning experiences, we mean the dev sprints. Basically, dev sprints are 2-week simulation of developers squad in technology companies. Participants learn about the technology, collaborate with other developers, and contribute to our open source projects, improving both their technical skills and soft skills like teamwork, communication, risk management, and so on. All this experience is led and monitored by an experienced developer, the tech lead. Who is the tech lead, you ask? So they are specialist developers in different types of technology like iOS and Android development and methodologies like agile development, who are responsible for leading and sharing knowledge during the dev sprints using daily live mentoring sessions. And our tech leads community is made up of experienced people who work in leading technological companies around the world, like Ricardo, who works at Meta, Ana, who works at Novoda in Barcelona, Spain, and our guest today, Emmanuel, who works at Delivery Hero in Berlin. When you join Dev Sprint, you get 10 hours of live interaction with this experienced developer, the tech lead, hands-on experience and portfolio for your resume, and access to our global Devpass community with exclusive discounts for the next sprints. There are a lot of people today already enjoying this great experience we offer. One of them is Razi. Razi is an iOS developer who already attended 4 dev sprints, where she made 9 open source contributions to our projects, practiced her skills in code-based UI development, like Vue Code, Swift UI, and iOS fundamentals. All her code was approved and reviewed and approved by tech leads such as Ana, Eduardo, Firais, and Ricardo. So, at last but not the least, as we have a very special day today, we want to celebrate, and we are offering you 15% of discount in the upcoming dev sprints for the global community. So by following this QR code, you access the dev sprint list already filtered by the sprints which use the English as the main language. So take a look in the sprints, in the themes, the tech leads page, choose your preferred one. And when you reach the checkout page, you can use this special code in order to get this great discount. Before passing it to Emmanuel, tech leads, you that are senior developers, experienced developers with 6, 8, 10 years in the market, if you in some way got interest about what Devpass is being doing, please join us, join our tech leads community. Just follow this link, devpass.com.br/en/join. We will get in contact with you soon in order to explain all the value we are bringing for tech leads and experienced developers as well. So I think we are ready to start right now. one last thing is that please use the chat here on YouTube in order to send your questions, and we'll have some minutes in the end of the presentation in order to answer them. Okay. So that's it. Thank you again for joining us today. Enjoy Emmanuel's talk, and that's it. Emmanuel is with you.
Yeah, thanks, Rodrigo. And yeah, I'm really excited to be here. This is going to be an interesting session, hopefully. And so, my name is Emmanuel, and I'm Nigerian. I've been an iOS developer for a couple of years. And in case you don't know where Nigeria is, it is somewhere in Africa, right? You can just look for it. But anyhow, I have an accent. So if I say something that sounds weird, then feel free to just confirm by asking in the comments, right? There was a time I was like having a conversation with a friend, and I said that I don't like beds. And he was shocked. He was like, then how do you sleep? I said, no, no, not beds, but birds. Well, so something like this you may encounter, but if you do, just feel free to clarify in the comments. So today we're going to be learning about auto layout, and this is a very important topic. I can't stress it enough. And I've seen a couple of people that basically rushed through this process, and in the end, they found themselves struggling with like views and how to basically create layouts that are flexible and scalable. So this is very important, and I would really urge you to pay attention, right? But at the same time, it's also simple. So feel free to just relax, grab your coffee, and just pay attention, all right? So we're going to be learning about auto layouts, but before we get into the main thing, I would like to just clarify some terminologies that we're going to be using. So you would often hear me say things like points or pixel. And whenever I say this, I'm basically referring to like a measure of distance or a particular location. Now in iOS, we use points, but depending on your background, you may have been using pixels in the past. So for the sake of simplicity, whenever I say point or I say pixel, I'm basically referring to a particular point in your screen, like a location or like this, or I may just be using it to specify like a range of locations. So maybe 100 points or 100 pixels is the width or height of a particular view. All right. Another terminology that I will be using is frames. And basically what frames is location and the size of an object or a view. So whenever you have something or a view on the screen, right, it is in a specific position and it has a specific size, right? So looking at our example currently, we have the X position of 100 pixels or 100 points, and then we have the Y position as 150, right? There's one thing I'd like you to pay attention to, and that's the fact that the points are starting from the top left corner. So the top left corner of the device and the top left corner of the view, right? So this is very important. So you can just imagine yourself as like holding a piece of paper and you are holding it at the top left corner, right? And if you want to place that paper on any part of a board, you place it holding that particular spot or that particular point, all right? So whenever you're trying to place an object or a view on your in a view or in your screen, right? You you think of your position from the top left corner. Okay. So in this example, we have X value as 100 and Y value as 150. So apart from that, we also have two more values, the width and the height. And in the case of this example, we have the width as 100 and the height of 100. Okay. Now, the thing about frame is a combination of all these values. So if you put them all together, you'd have your frame as X 100, Y 150, width 100, height 100. Okay. So this is basically what makes up our frame: the X position, the Y position, the width, and the height. Then finally, another terminology that you would hear me use very often is constraints. And constraint simply means a fixed rule. And it's something that you're going to be hearing a lot about because that's what auto layouts is about. And if you were thinking about maybe the kind of constraints that happen in movies like The Exorcist or Constantine, where they just bind demons on the bed and chain them like that. So it's the same concept, right? We do that because we don't want the view to basically just act as it is, or we don't want it to stay in a specific position or like frame depending on the different devices. Because working on as an iOS developer or a mobile developer, or even a developer in general, you'll be dealing with like a dynamic range of devices. You have for iPhone, you have like iPhone 4, 3, 1, X, 13 Pro, iPad, watches. Like you have a whole lot of screen sizes. And when you are building your app for iOS, for example, you want to make sure that your apps are flexible enough to look good on the smaller devices or the bigger devices, right? So that's what constraints is about. And in to give a visual representation is like you have a view, just like you see here, and then we add to, in this case, we have two constraints, and we are basically fixing them or adding a rule to make sure that this square is always at the center of the screen. Okay. And one thing that you can also keep in mind is that constraints can basically influence the frame. Okay. So for example, you can have constraints to the left and the right of the screen, and then at the time of development, the width is maybe 100, but when you run it on an iPad, the width is maybe 300. All right. So that's something to also keep in mind. Constraints are basically rules that guide how your views react based on like the different devices and the different screens. Okay. So now that we've gotten the terminologies out of the way, why exactly do we need auto layouts? Why should I care? Why can't I just like put stuff on the screen and have it work everywhere? Okay, so that is what we're going to be covering, or that's the question we're going to be answering now. And the answer is actually very simple. It simply means, or the reason is for responsive design. And just like I hinted earlier, responsive design means that you are creating a layout, or like you are putting maybe a structure in place, and this structure is able to react or basically respond correctly to different screen sizes. All right. So you have if you build your app on an iPhone X design or an iPhone X template, and you have your views laid out, but when you run it on an iPhone SE, which is much smaller, the views still look right. So everything, the views basically reacted or adjusted in a way that the layout isn't compromised. Or if you were even going ahead to run it on a bigger screen, on an iPad, for example, or even a maybe 13 Pro Max, then your layout also expands in a way that it fills out the screen in a proper way. So I'm going to give you some representations of visual representations of what it means to have responsive design. And you can see here we have like a view that doesn't have auto layout. And you notice that when we rotated the screen, the width was constant, like the width didn't change. And so because of that, we just had like half of the screen blank, right? And this is not a good experience that we want to give users. I'm sure they will just bombard your App Store reviews with 1 stars. But anyhow, so this is you not having auto layout. But if you add auto layout to this design, you see how like easy and clean the design is just going to look. So now we are able to scroll. We are able to see the view basically uses the entire width of the screen. So this is like your with and without auto layout. I'll give you another example. So here we have no layout and we built on iPhone X and everything looks good. Fine. We release this to production and then someone runs the app on an iPad and then they are seeing a portion, like the entire app on just one small portion of the screen, and the like 2/3 of the screen is just blank. Again, that is not good experience. But then if we go ahead to add auto layouts, looking at it on an iPhone X again, it looks very good, no difference. But then when we run it on an iPad, you can see that it actually expanded to the view. So this way we know that we set a constraint for the view to always fill the container or the device screen, right? So now that we've seen why we need auto layouts, let's actually take a moment to go through some of the constraints that we have in iOS. Or yeah, so there are a lot of constraints that are available, but we're going to just try and go through the common ones, and then hopefully sometime in future we get to use more interesting constraints. But the first one, and also very popular one, is leading or left. And these are actually two different things, but thinking about it generally, it is constraints added to the left side. So we have a view on the screen, as you can see, and then there's the arrow going to the left. Basically, it's just, you can think of the view as a human, and then adding left constraint or leading constraint means you are stretching your left hand and you are holding someone that is beside you. Okay. And in this case, this is the square that is stretching the left hand and is holding the view, which is in this case the screen, the parent. Okay. And I mentioned that leading and left is different. The difference is that when you say left, it is always left. You are always stretching your left hand. But for when you use leading, leading basically means that you are, for if the how do I say this? If the language is moved from right to left, so if you read your language from right to left, just like we do in English, we read from left to right, not right to left. So if your language goes from left to right, then leading is going to be left. Okay. But if your language goes from right to left, which I think like Arabic does that, so they read from the right to the left, in that case leading is going to be right. Okay. So leading, you can think of it is the direction or the point where you read from. Okay, so if you go from left to right, leading is your left. If you go from right to left, leading is your right. Okay, and in most cases when you are developing, you'd want to do this, especially when you're working with labels. You want to use leading so that the constraint is at the left and not is at the right, rather, so that they are not reading right from the left. It sounds a little bit confusing, but just keep that in mind. Whenever you want your view to always be at the left position, regardless of the country or the localization, use left. But if you want it to be flexible enough to adapt to the countries and the way the readings work or the direction, then you use leading. Okay. And the same thing works for trailing, and trailing goes to the right. So the trailing is the right hand side. The same logic for leading is the same for trailing. Next, we have the top constraint, and top constraint basically means that you are trying to, just imagine you stretching, you have a hand on your head and you're stretching it upward and grabbing whatever is on top of you. So that is the top constraint. And then we also have bottom constraints. I'm sure you may have guessed, is you having, okay, this time you have legs, so you can just use your leg to grab whatever view is below you. So the idea of these things are, whenever you set a constraint to any particular portion of your screen, you are basically creating like a clip. Again, just imagine that you are holding it. If we were to add just the top and the leading constraints for this particular square, then the view will always be at that position regardless of the orientation. If we were to add the bottom and the trailing constraints, it will always be at the bottom right, regardless of the orientation of the screen size. Okay. So another common type we have is center horizontally. And basically what this means is we have a view and we're just going to put it in the middle of the screen along the x-axis. All right. So center this horizontally. So put the view or whatever it is at the center of the screen. Another common one we have is center vertically. And just like center horizontally, it means you're going to center the view, but this time you're centering it on the y-axis. So it's going to be centered at the middle of the screen. Okay. Then another constraint that we have is width, and width is actually used quite often because there are times maybe you want to add like imagine your profile picture, for example, or a particular small icon you want to have on your view, and then you can just specify the width so that it is always that size. So you can specify a width of 100 points or 50 or whatever. And the same way we have width, we also have the height constraint. So you can also specify the height constraint of a view. So one thing you need to know about this is whenever you specify the width and a height constraint of a particular view, it will always be that height. All right. So it will, if you set it to be 50, it will always be 50, regardless of how big the icon is. So if, let's say, for example, you add a picture that is like 300 pixels by 400 pixels, and you set a width and a height constraint of 100 or even 2020, the image view is going to be the same size as the height constraint. So the constraints take priority because you are basically setting a rule and you can't break it. Okay. Then the next one we have is aspect ratio. And aspect ratio is quite similar to width and, in fact, it is width and height, but there's a lock, just like you can see in the icon there. So aspect ratio means that you are going to be growing or setting the dimension, the width and the height of a particular view, and it's going to expand or shrink based off of a specific ratio. So if, for example, we set this ratio to be 1:1, it means it's going to grow at the exact proportion. Just like you saw, it's going to just grow the width and the height. So if you run it on bigger or smaller devices, it's going to adjust the width and height of this particular view. Okay. Then we also have equal width, and equal width basically means you are setting the width to be equal to the width of something else. All right. And the beauty about this is you can set the width to be the same as the width of another view. You can set it to be the width of its parent. So I can basically make this view to be the same width as this width of the screen, right? And you can also go one step further and not make it the exact width. So you could also specify the multiplier, where if the value is 1, it is going to be 100% equal. But if you were to set the value to be maybe 0.5, then it will be 50% equal. If you set it to 0.1, it will be 10% equal, right? So they will just like the Xcode is just going to do the calculation and then just make sure that it is X% equal to this other view, all right? And the exact same concept applies to the height. So we can set two views to have the exact height. Then another thing that we can, that is worth noting about this is whenever you set a view to be equal to another view's width, if something else, like if another constraint modifies the view's frame to grow, then your view is also going to grow. So you can think of it as chaining width constraints. It's like I'm going to grow bigger if X person grows bigger. I wish that happens. If I could just chain myself to the rock and then he goes to the gym and he works out and I become bigger. Anyhow, it's the same concept that works here. If you set a width to be equal to the width of someone else, then if you modify the width of that, it's going to modify the width of yours. All right, so how exactly, we've seen some of the common constraints. So how exactly do we add constraints to a view? So this is a simple demonstration here. We have a simple label on the screen, and then you just click on the button at the bottom right, and then you can see that we have basically 4 edges where you can select whatever direction you want to add the constraint. So from the last slide, you saw that we have top, leading, trailing, bottom. And again, if you look at this, you see the top. So I clicked on the top and I clicked on the leading. You can also click on trailing and bottom, and then it's going to add the constraint just like that. The same time, you can also go ahead and specify values. So if you wanted it to be 10 points to the top, then you change the value to 10 points, or If you wanted it to be 10 points to the left, you change the value as well. So this is a very straightforward way and simple way of adding constraints. Another way we can add constraints still with button clicks, but this time we are basically modifying the alignment, and this is us setting making it to be centered horizontally and also centered vertically, right? So this is a visual way of just adding these two constraints very easily. Another way that we can add constraints and is actually quite interesting is holding down control, click, and then so you hold down control, you click on the view that you want to add the constraint to, then you drag it to whatever view you want the constraint to basically apply to. So what I'm saying in essence is this: whenever you want to add a constraint, right? Imagine you want to grab, you want to hold someone, you need to know who you are going to hold. You need to know basically, yeah, who do you want to grab, right? So when you hold down control and then you click on your view, the next view you drag it to is basically the view that you are going to be holding or the view you are going to be adding your constraint to. So the same way we dragged from our label to our device view, you could also add or drag from our label to a different label. All right. So in this case, we're just adding center vertically and horizontally to the parent. We could center horizontally and vertically to a different view. Okay. So it's just something worth noting. So now that we've seen how we can add constraints, how can we see the constraints that we've added? Because it's actually very important. And I'm sure you already saw this in the last slide, is whenever you add a constraint, there's a visual representation right there on the screen. So in this case, we can see that we have two arrows because we added, remember we added two constraints, the horizontal constraint and the vertical centered constraint, right? And those are the two blue lines that are used to represent these constraints. And another thing that's worth noting here is that if there's any issue with your constraint, if for any reason the constraints are wrong or something is not good, then these lines will be red. Okay, so if the lines are red, something is wrong, you have to look into it. Then in some cases, you would also see the line as orange, and orange simply means that the constraint is there, but it's currently not active. So if, for example, you've added a constraint and you just drag your view away from its original spot, the constraints are there, but it's not taking effect because you manually moved it out. So you can refresh the view and then it will just snap back in. But even though you don't, whenever you run the app, it will just snap back in. So it's just like telling you that, okay, this view is here, but this is not the constraint that is being executed there. Okay. So another place that we can see the constraints is just right there at the left. You can see where we have the drop down for constraints, and we have the two constraints that we added. We have the center Y, which is center vertically, and we also have the center X, center horizontally. All right. So those are the two constraints we added there as well. Then another place we can see them is right at your left, where you see, first of all, you can see the cross sign that shows basically the two constraints that are currently on that particular label. Then you can also see the constraints there as align center to super view, align Y to super view. Okay, so these are also, you can also find your constraints here as well. Now, if you were to select any of the constraints at all, you would see the full details of what the constraint is, or like the properties of that particular constraint. And in this case, we selected the X, so center X, center horizontally. And you can see the first item. The first item is what item is this constraint added to? And in our case, the constraint was added to label. Okay, so the first item there is label, and we are centering X. So that's what the constraint is. Then second, we also have the relation. And what this relation simply means is there are certain, you don't always have to set your constraint to be equal to a value. You can set your constraints to be less than or equal to. You can set your constraint to be greater than or equal to. You can set it to be equal to. So basically, you are saying, so if, for example, I wanted to specify the width of this label as 100, it means that the width of this label will always be 100. Okay. But it is also possible for me to say, okay, I want you to shrink the button, but it shouldn't go past 100. So maybe when you add some content, the button will grow, but it shouldn't grow past 100 pixels or 100 points. So you can specify that in the relation where you say it is less than or equal to then the constant, which is the next, okay, not the next, but the next two, but less than or equal to the constant. But before we get to the constant, let's look at the next one, which is the second item. And the second item, just like I said again in the past, was whenever you're adding constraints, you are trying to hold someone, right? The second item is the person you are going to be holding. So in our case, so far, what we've been doing is we've been trying to hold our parents. So the parent is where our view is added. In this case, the view is just added to the screen. So the super view is our screen. So the second item is that parent. Okay. But if we're trying to add this view, or if we're trying to add this constraint to a different view that was within the same parent, then we would not see super view, but we'd probably see something like label 2 or text field dot center x, whatever. Okay. So the second item is the view that you're trying to grab or add your constraint to. The first one is you, second one is the other person. The relation is what condition does this rule need to meet? Should it be equal to, should it be less than or equal to, should it be greater than or equal to, whatever. Then the constant is the value of the constraint. So currently you can see that this label is dead in the center, like it's at the exact middle, which is 0, right? So if we were to change the value to 100, then the center will be, the constraint is going to be the center plus 100. So it's going to move to the right by 100 points, okay? Then if you set it to be negative 100, it will move to the left by 100 points. And the same logic applies to the y constraint, or the center vertically constraint. So if you were to set the value as, if you set the constant as 100, it would move positive. So it will move upward 100. Then if you set it negative 100, it will move downward 100. Okay. So that's just something to keep in mind. Then identifier is if you want to be able to identify the constraint somehow later and then just bring it, like modify it somehow by code, but you don't need to be worried about that for now. All right, so that's about viewing constraints. So let's talk about the mistakes that people make. So you know how they say with great power comes great responsibilities. So there are people that would, because they have all this power, they use constraints anyhow, and you'd see them adding so many constraints into a single object, and then many things go wrong. Okay, so we're basically going to see the some of the mistakes that people make. One of the mistakes that is quite common is incomplete constraint. And basically that means that you give some conditions, but it's not enough for the system to make an informed decision. So let me see if I can give a typical example in real life. Imagine you go to court and you tell someone that this person stole a book or something, but there's no evidence. So it's hard for the judge to make a decision. They can't, strange things can happen, right? They can decide to just find the person guilty or innocent, and it may not be correct, right? So the same thing applies here. If you give incomplete rules or incomplete constraints, then it's harder for the system to make the right decision on where to put what view. And remember, when you run it on the device that you built on, it may look good, but when you run it on a smaller device or a bigger device, or you change the orientation of the device, then everything just becomes messed up. So this is something that you always need to be aware of. And if you also look at the top left, you would notice that beautiful red icon that has the arrow. And basically what that does there is it tells you or screams at you that, look, something is wrong here. So you have to just click on that. And most times, to some extent, the descriptions are quite helpful. But sometimes listening to them is going to cause more harm than good. So it's always important for you to know what exactly you want to do, and it is going to help your decision. And this is a typical example of what I mean. So you see in the first image, I have a label that is centered horizontally, right? But we didn't center it vertically. But what I want to do is I want to center this vertically. But if you look at the hint or the prompt at the top left, you notice that they're saying something that it needs constraint for Y position. Now, thinking about this statement generally, I would feel like, okay, so it means I need to add the Y position, or like I need to add top constraint to this view. But if you go ahead and add top constraint to this now as it is, it's going to look perfect, right? It's going to look very nice on this device because you're adding your constraint to meet this need. So let's say, for example, you add the constraint to be like 400 points, then it's going to remain at the exact center, okay? Which is good, which is what the QA said you should do. You did it, right? But then you run this app on an iPhone SE, which is a smaller screen. Now, because you specified a fixed height of 400 points, it is always going to be 400 points. So when you run it on an iPhone SE, it is not going to be at the center in the Y axis. So it is going to be closer to the bottom. Okay, so this is just something that you need to keep in mind. What exactly do I want to achieve here? What constraint is going to help me achieve that best? So in this case, what I really want to do is to add a center vertically constraint. Okay, and you already saw how we can add that by using the alignment button, or you hold down control click and drag. All right. So that's one of the very common mistakes that we make when using constraints. Another one is conflicting constraints, and this is a very simple and quite common case that people make, even though it's easier to debug in this case. But you can see that we specify the width of this label to be 100, and then later on we specify the width to be 60. Okay, this is a very simple case where this can happen and it's easy to debug, but there are cases where you won't be able to, and I think we're going to encounter that in a few minutes. So don't worry, you're going to see that. But this is in general one of a very common mistake that people make, is where constraints are basically conflicting. So another conflicting, or another instance of conflicting constraints, is where you maybe add leading constraint of 100, and then you add a width of 100, and then you add trailing of 20. So when you do this kind of thing, what is going to happen is that the width of the label you've specified should be 100. But then you've said that this label should also grab the right side by like with 20 points. So by grabbing it to 20 points, it's going to try to stretch the label, but when it tries to stretch the label, it's seeing another constraint that is saying the label shouldn't stretch past 100. So in that case, now these two constraints are impossible to satisfy together. And then you would have like some strange things happening on, and your compiler would also even scream at you. So yeah, that's also one mistake that people make. And the next one, which is I think my favorite, is what I call absolute confusion. And this is where many things are happening and many things are wrong. There's no one fix or just one button that just fixes everything. And if you look at this image, for example, that I've added top constraints, I've added left, I've added right, for the two squares, and I don't know what else to do. Why isn't Xcode just helping me out? So if you look at the troubleshooting, or just look at this, you notice that there's no, when it tries to drag the view upward, there's no height. So it doesn't know what height to give the square. So if it's dragging, it's basically just doesn't know what to do with the height of this square. So a simple way to fix that is to add height to both of them. And when you do that, you now see that, okay, yeah, the Xcode is happy, saying, yes, I have the constraints, I know what I'm doing. But then there's one more problem, okay? And that's the fact that we are saying that the first view should hold to the right, to the left, and should also hold the right of the second view. And the second view is saying hold the or the second view is being held by the first view, and is also holding the parent. But these two views don't know what their size should be, right? So the size is unknown. And because of that, Xcode can't also guess what the size should be, because these are two views with no content whatsoever. You can't set the size based on a particular, maybe the text or whatever. It's just completely blank. So Xcode doesn't know what to do. Now, if you look at this, a simple solution again that you can take is to give one of the views a width, right? And if you give the left view a width, you notice that, okay, the right guy is now, okay, I'm fine now. So the first view is always going to be 100 points. Then for the other view, just stretch to the remainder of the view. So if the screen is smaller, the view should become smaller. If it is an iPad, it should become bigger. Okay. And we can actually just go ahead and see what it looks like on an iPad. And if you look at the bottom, you would see where we have iPhone 11. So if you click on that button, you would see we have iPhone 11 and then we have iPad. So if you want to run on a different mobile device, you click on iPhone 11 and you see all the devices are there. But if you want to run on an iPad, you click on the iPad and select the device. So if we just go ahead and select this just one device, you would notice that this is what we're saying. So this is responsive, right? Because the first view maintained its width and its height, while the second view just grew depending on what the screen's width is. Okay. So, but what if I don't want this? I want the two views to always be in the middle. Okay. I want the two views to always be in the middle, but they should grow or shrink depending on the width of the screen. Now, this may become a little bit tricky, but what you can do is you can put someone in the middle who you can call a guard. All right. So when you put the guard in the middle, then the guard is basically going to have its own fixed width, so it doesn't move. It's going to be constrained to the middle, and then it's going to pull the left and the right views together. And this is basically what I'm describing. So you can see we have one view in the middle, which I'm calling the guard, or the whoever is just going to help them settle their dispute on who should be bigger or smaller. So this view is in the middle, and then this view has a fixed width, and that's actually very important, because if the view doesn't have a fixed width, then the view is going to join the fight in, I don't know who is going to be this big or this small. Okay, so the view has its width, and then the view now holds both views together. So remember, they're already constrained to the screen, the edges of the screen. So when this middle view holds them together, they'll basically grow and shrink depending on the device. Then I also added two more constraints to this view, even though they are not very visible. And what I added were like top constraints to a view. All right. And basically what that means is I didn't add for the middle view, there is no top constraint to the parent, okay? But there is top constraint to the blue view. So we're basically saying, hey, my top should be the same as your top, all right? So that's basically what is happening here, but don't worry about it too much. I'll also see it in practical when we get to do like the workshop. So that's it for absolute. And then if you go ahead and run it on an iPad, you can see that the middle guy remained in that position because it was constrained to the middle and it has its fixed width. But while the screen grew, then the two views at the left and the right grew along with the screen. Okay, so that's just, it shows you like how you can have like two equal views, and it is also responsive depending on the device. All right, so this is, I've covered many of the constraints. I've covered how we can view them, how we can create them, some of the mistakes people make. So I'm just going to ask just a few questions to you guys, just to give you a while to just think about it. But let's see this first one. So we have this view on the screen. Can you figure out what is wrong with this particular view? What constraints are not good, or what constraints can we add to make this better? Can you just think about it? Just look at it and just think. I'm just going to count to three. and then I'm going to give my answers. But you can go ahead and just drop your answers in the comments. All right. So 1, 2, 2, 2, 3. All right. So if you look at this view, you would notice that we have that top, that straight line that goes from the top to the bottom. And basically what this means is there is a center horizontally constraint. Okay. So there's a center horizontally constraint, which is fine. But then we also see that there is a leading constraint, meaning there is a constraint to the left. All right. Now keep this in mind. There's a constraint to the left. There's a center horizontally constraint. This means that the view should be both at the middle and at the left. But then again, there's one more constraint that is causing the problem, which is the width. So we're saying that this label should have a width of 100. So now the conflict is between, should I maintain my width, or should I center this view, or okay, this one is not all, but I have to stay anchored to the left, or maybe should I even stay anchored to the left? So these are three conflicts that Xcode is currently having, and like, please, why are you confusing me? So there are multiple solutions you can give to this. For example, you can decide to just delete the width constraint, and if you delete that, what is going to happen is the label is going to stretch to the other side of the screen. So it's going to stretch to the right side, because it is going to try to conform to the center horizontally constraint while staying pinned to the left. So it's going to hold the left and then drag the view to the middle. And when it drags it and is anchored to the left, the right side is also going to drag automatically. So if you were to remove the width constraint, then you just have a view, the label is going to go from the left all the way to the right. Okay. Another thing you can do is to remove the center horizontally constraint. And if you remove that, the view just remains on this exact spot because it has a fixed width and it is anchored to the left, right? So that's another solution. It just depends on what your design should look like. Do you want it to be centered to the middle? Do you want it to be like anchored to the left? All right. So yeah, that is just one question I wanted to throw out. And there's one more thing I wanted to mention just about this is when since you have the content or the label with the text, you don't need to have the width if you want it to grow with the content. So by default, the frame of the label is going to grow based on its intrinsic content size. And in this case, the size is stops at label, right? So the frame or the width of the label is going to be from L to L, and it's just going to be like that. Then if you add more text, the size of the label will just continuously grow, right? So, but yeah, these are just like things you need to be aware of. Now, the second one I have is this, and this one is a little bit tricky, I think, because, in fact, tell me, can you spot any problem with this? If there is, or maybe I'm just asking a trick question, but can you tell me what is wrong with this particular view, this particular screen? If there's nothing wrong, then go ahead and just let me know because you are probably right. But if there's something wrong, also let me know and let me know what you think is wrong because you're also probably right. So I give you to the count of 3 to give me an answer. 1, 2, 3. All right. So let's look at this view. So we have the top constraints, we have leading, we have trailing. That's fine. We have the height constraints, perfect. But then there's one more constraint in the middle, which is the width. So we're basically giving the label, we're asking the label to have a fixed width. But then we are setting a leading and a trailing constraint, meaning that on a bigger device, it is going to try to drag the label. On a smaller device, it is going to try to shrink the label. And when it's trying to drag or shrink the label, then the width is going to become an issue. So currently now we see that there's no red like warning or error kind of indication that there's something definitely wrong with this constraint. There's a warning, and the warning actually makes sense because they're telling you that based on the current constraints you have on this view, you could potentially run into some issues in different other devices. And that's what is going to happen. If you run this on an iPad, then you're going to have like conflict between the width and then the leading and trading constraint. All right. So that's it for the presentation. And in conclusion, I just want you to I just want to paint one last picture, one last image of constraints. Whenever you want to add constraints again, just imagine that you are standing in an assembly ground and just holding your partner. All right. So you have your right hand and your left hand, and we've not evolved yet to the point, but maybe we have hands on our head and we have our feet, right? So you are able to grab in all directions. You can hold on to people. You can just basically attach yourself to different positions in a particular field, in a particular frame. All right. So all you need to do is think about the how do you want your view to react? How do you want it to react depending on the way you grow, or the way the screen grows? Do you want it to grow with the screen? Do you want it to remain pinned to a corner? Do you want it to be the same as the width of a different view? Do you want it to be at the top of something else or the bottom of something else, or do you want to center it within something else? So you just think about all these things and think of how the just imagine the screen growing and the screen shrinking. How do you want the constraints to react, right? And then with this, you'll be able to basically just make more informed decisions. And I think one rule of thumb is try as much as possible to minimize your constraints. So the more constraints you have, the more potential for problems, right? So try as much as possible to achieve your layout with minimum constraints, as few constraints as you can, all right? And then you hopefully run into less problems. Then also, this is just my promo code. So go ahead and just use this to create or to sign up, because sometime in future, I think in August and in September, we're going to have the actual hands-on experience where we're going to build stuff, and it's going to be very exciting. So if you feel like working with me, then just go ahead and take this 50% discount chance now, and then we can just go ahead, and I look forward to seeing you guys there. Anyhow, guys, peace. So this is the end of my presentation.
Hey, Emmanuel, thanks a lot for your presentation. Congratulations. I
Thank you.
must say that I loved your example with the hands and feet. I'm not sure if I would like to have a hand on my
Ah,
head, but it was
I don't
a
want.
great example. I think I'll use it on the sprints in Devpass. So
Yeah.
we have some minutes for question. We actually have some questions. I would like to start with one from Code with Lima.
Okay.
Actually, this question was sent during the first question of the quiz.
Okay.
So can you see it in the screen
Okay. Does this
here?
mean that the middle view would have to be transparent to give the illusion of padding? Okay. So I'm assuming she's talking about the label, right? So yes, it again depends on okay. Oh, I think she's talking about the one where we were centering the two views. Yeah, I think so. Yeah, because of the illusion of padding. So yes, of course, that the reason I used the black was to just give a visual representation that there's something there, all right? But in the real sense, I would probably use a transparent view, or maybe just use a stack, all right? So it just depends on yeah, whatever solution, but definitely you don't want to use a color that is going to give it away. So yeah, transparent.
Great. We have other questions from the DevPass community. The first one is auto layout libraries like Snapkit, cartography. When to use? What's your preferred one? And do you recommend it for junior devs?
I'm sorry, can you ask again?
Yeah, the question is regarding auto layout libraries like
Okay.
Snapkit. Have you ever used one of them? Snapkit, cartography,
Mm,
third-party libraries that help us to build the constraints by code.
mm. So personally, I've never been a fan of like using libraries, and I know there are people that basically use libraries to make things easier, which is good. It makes sense for you to try to make life easy for yourself. But personally, I think I would always recommend juniors, especially, to start with actual development. So it is best for you to understand what is happening, and then when you understand, then you can choose to make life easy for yourself, if that makes sense. But speaking based on personal experience, I've always chosen to build. I always build what I want to use the first time, like the first during my learning phase. I always build, right? And then while I'm maybe working for my organization or working in bigger teams, definitely I would use like libraries that make it maybe more accurate and have like performance benefits whatsoever. But initially, I always go with like learning and using the native provisions or the native solutions that are available. Okay, just like
Nice.
for this constraints in general, right? If you understand the core of constraints visually, like with storyboards, when you try to write your constraints by code, it is very easy. Like you write it almost without thinking, because okay, I have this view and I want this view to go to like to be constrained to this view. I want this one to be constrained to this view. So your decisions are your own, right? You don't just assume or just hope that the compiler or the library helps you. Yeah,
Another important thing is that all these third-party libraries are built upon the native
exactly.
UI kit libraries, right?
Mhm.
So if you learn at first the native development, whenever you join a team that is using one of these libraries like Snapkit, Cartography, it will be
Mhm.
easier for you to understand and work with them.
Exactly.
We have another question about iOS UI development.
Mhm.
That is when we need to worry about size classes, right? So when we are developing UIs for iOS, you will get to constraints and out layouts soon. But when we need to worry with about size classes, when we need to use it, to learn it.
Yeah. So actually personally I've never had to worry about like size classes. Like I've always and I know like so with size classes you are trying to add certain constraints to a certain group of screens or the certain group of screen sizes. So maybe you want like a few iPad screens to use this constraint, right? So personally I haven't had to do that in the past. And so yeah, just most times I try and make sure that my constraints are just very much adaptive to all, and so that I don't have to start adding individual constraints to individual views, because when you start adding like constraints to certain classes, then in some if you just think about it generally, you're also creating that kind of there's a new level of complexity that has been introduced, because now you have to be deliberate and cautious about what you do with this group of screens and what you are doing with a different group of screens. So yeah, I don't know. Personally, like I said, I've not had to build certain or individual constraints for certain views or certain classes of screens.
Yeah, I already had the experience of working on an app that have had iOS and iPad different UIs, right? And for
Mhm.
example, in one of the detail screens on iOS, on iPhones, we have to have a collection view with just one column. But when this screen is open on an iPad, this collection view has two columns. So this is a perfect example when you have to use size classes in order to identify the size of the screen and apply the changes in your UI. So
Yeah. But
please.
in that particular example, personally still wouldn't use like size classes, because if I wanted to have different columns for different screens, I would most likely just either use compositional layout or just even the conventional flow layout. So then I would just do my calculations. If I were using flow layout, I would do my calculations based on the screen size, right? But again, I'm not adding individual constraints for certain cells for different device groups. So if I were using a collection view, and I was using compositional layout, it's even way easier, right? I actually even just released a video maybe last week or last 2 weeks, I can't remember, about compositional layout, and it just makes life easy. The main thing, just like I said earlier, is try as much as possible to minimize your constraints. And the fewer you have, the less room there is for like problems. But the more constraints you have and more constraints for specific device groups, then you are also, it may work, right? But it may also expose you to more problems down the line. But yeah, that's just it.
Great, thanks for sharing.
Yeah.
We reached the end of the our tech talk. Before we end, I would like to remember for those who weren't here in the beginning, we are Devpass, a platform where tech leads share knowledge through live sessions, and we have a special discount of 15% for our international dev sprints. So just go to this QR code or visit our website and use Emmanuel's code during checkout to get the discount. If you have any doubts, please contact us through our email, WhatsApp, or our social networks, and we will get back to you very soon. So,
Makes sense.
Emmanuel, thanks a lot to join us for today. It was a very good talk. I think this is the content you shared is not only important to beginners, but for all levels, because trust me, no matter what level you have bad times with constraints soon. So it's very
Yeah.
important you bring those examples and stuff. So thank you so much.
Thank you so much for your time.
Great. See you on the next Tech Talk or in the next Dev Sprint. Please take a look on our site and register. And that's it. Follow us on YouTube, and we talk again other day. See you. Bye bye.